Lesson 4.1, mean, median, and mode. Our objective for this lesson is to be able to calculate the mean, median, and mode for a data set. Let's start by defining distribution. Distribution refers to the way the values of a variable of interest are spread over all possible values. So when we talk about a data distribution, we're interested in what's the lowest value in the data set, what's the highest value in the data set, and what is the typical value in the data set, or where is the center of this distribution. And so with today's lesson, we're going to be talking about 3 ways of describing the center of a distribution, or the typical value in a data set. So the first way is with mean, and mean is what we usually associate with the word average. When we talk about average, we usually mean mean. A mean is the sum of all the values in a data set divided by the number of values in that data set. So it's what we typically think of when we think of average. Median is the middle value in a sorted data set, or halfway between the 2 middle values if the number of values is even. So if we have a data set with an odd number of values, then we'll just sort them from least to greatest and then figure out what the middle value is, and that's our median. Now, if there are an even number of values in the data set, we still sort them from least to greatest, but then there's going to be 2 values in the middle, and to find the median, we're going to choose the value that's halfway between those 2 middle values. And then there's mode. So mode is just the most common value or group of values in a distribution. Mode isn't always going to find the center of a distribution the way mean or median attempts to do. But sometimes mode is the best way of describing the typical member of a data set. And so it's found just by simply looking at what value appears most often in the data set. Finally, let's talk about outlier. So an outlier is a data value that is much higher or much lower than almost all other values in a data set. And we're going to be talking about outliers in relation to mean and median because an outlier can really affect a mean. If you've got, let's say, all the values in a data set are right around 10,000, and then you have one value that's 1,000,000. Well, if you add up all of those values and divide by the number of values, the way that you would calculate a mean, that 1,000,000 is really going to affect the results. If you threw that out, you would have a much lower value than if you kept it in. That's not true with median. An outlier doesn't affect the median the way that it affects the mean. And so we're going to be talking about how we're going to choose whether we're going to use mean or median, and it's often going to depend on the existence of outliers. Our example gives us the price of milk at 8 different grocery stores in our area. And the first question it asks us is to find the mean, median, and mode for these prices. So to find the mean, what we're going to do is just add up all of these prices. And then there's 8 of them, so we're going to add them up and divide by 8. So if we add up all of these prices, the 9s are going to add, there's 8 of them, so 9 times 8 is 72. And then we've got 7 plus 15, 30, 43. So then 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. So 21, all of these together is $21.32. If we divide that by 8, 8 goes into 21 twice with the remainder of 5. So 53, 8 goes into 53 6 times, the remainder of 5. 52 also 6 times with the remainder of 4, and 40, that would be 5. So 2.665. So $2, our mean is going to be $2.67, rounded to the nearest cent. All right. The median now is, we need to first arrange these in order from least to greatest. They're not in any order right now. So let's find the lowest value and call that 1. This is the lowest. We'll call that 1. And then there's 3 at 229. So 2, 3, and 4. And then there's 2 at 249. So 5 and 6. And then 7 and 8. So those are the order of the prices from lowest to greatest. And we want the middle two numbers, so 4 and 5, so 229 and 249, and the median is going to be halfway between those. So the median is going to be $2.39. And then finally, the mode is just going to be the value that shows up most often. So we have 3 that are 229, so that's going to be our mode, is $2.29. All right, now we're asked if there is an outlier in this data set. And there does appear to be. This $4.49 is much more expensive than the typical price of milk. In fact, it's about $2 more expensive, almost twice as expensive as milk in some of these other stores. So, the second part of the question asks us to remove that outlier and see what the mean, median, mean and median would be without the outlier. So let's remove this outlier and then recalculate the mean and median without that outlier. So if we're adding these up, 9 times 7 is 63, 10, 12, 14, 18, 20 plus 18 is 38, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 83. And if we divide this now by 7, 7 goes into 16 twice with a remainder of 2. So 28, that's going to be 4. So $2.40 rounded. So this is now $2.40 is the median price without the outlier. Or sorry, the mean price without the outlier. The median, removing this outlier just means that now there's an odd number in our an odd number of values in our data set. Let's put our order up here. So we had 1, 2, 3, 4, 5, 6, and 7. And now our middle value is just going to be this fourth value. And so our median now is $2.29. Now notice that median would have dropped from 239 to 229 no matter how large this largest value was. By removing the largest value, we dropped that median down. But it didn't matter how big that largest value was. The mean, on the other hand, because that largest value was much larger, the mean dropped quite a bit more than our median. The mean dropped 27 cents from 267 down to 240. So that's mean, median, and mode.